Find the absolute minimum value of f on the closed interval from -6 to 5. So we know that f is differentiable, which implies that f is continuous. So that means we can use the extreme value theorem on this closed interval to find our absolute minimum. We need to start by finding our critical values. That's when our derivative equals 0 or does not exist. It only equals 0 at x equals -2, +2, and 5, which is also our endpoint. So now to justify our reasoning, to check which one of these values gives our absolute min, we're going to plug our critical values and our endpoints into our function f of x, which remember we've defined to be 7 plus the integral from -2 to x of f prime of x dx. So f of -2, we already know from the problem, is 7. That was our given initial value. F of 2 is 7 plus the integral from -2 to 2 of f prime of x dx. Well, that's going to be 7 plus this area. So from -2 to 2, it's actually an area, a net signed area of -2 pi. Now what's nice is we have already found f of 5 to be 10 minus 2 pi, and f of -6 is 3. So we're trying to figure out which one of these is the smallest value, and we see 7 minus 6.28 is probably going to be the minimum value. So we can conclude f has a minimum, better said, absolute minimum of 7 minus 2 pi at x equals 2 on the closed interval -6 to 5. So remember this, you need to state your critical values, you need to show justifying your reasoning in the table, and then state what you found.